In this video, we will see what is a model, how a model is built, a typical model building process, and what are the different types of models. Now, in this example, we are going to talk about how a model is built. So this is a typical model building process. Now, this can be applied to any classification problem or regression problem or any other problems. So this is typically how it is built. Now the first step is pre-processing the input data. Now why should we pre-process the input data? Why can't we take the data as such? Now data as such is called as raw data. So raw data may have issues with the quality of the data. For example, it could have missing information, it could have nulls, blanks, it can have invalid values, wrong distributions, etc., etc. So you need to first fix those values and then make the data all right. So the raw data has to be first converted into a pre-processed data, and then it can be ready for use. So first we pre-process the input, and then we split the data into two parts. So typically the split ratio is 70% and 30%. So the 70% data is called the training data, and on this data we have to train the model, that is apply the algorithm and build the model, and the remaining 30% is used for the testing purpose. Now, if my data is huge, I can take maybe 60% and 40%. But if I have less data, I can take 90% and 10% or 85-15, whatever may be the ratio. But 70-30 is pretty much the industry standard. Now, once I split my information into the train and test, so I'm going to take this 70% of the data and I'm going to build the model. A model learns the patterns of the training data, and it remembers them so that when it is applied on a different data which has a similar distribution, it is able to do a prediction. So think of model as a formula. So it learns the formula based on the training data, and then you supply some other data to it. So it applies the formula on the new data and it is going to do the prediction. So that is a model. Now, once the model is built, the testing data is applied on the model, and the model is going to give us answers in form of predictions. So if I have a regression model, I'm going to get the predictions as numbers. And if I have a classification model, I'm going to get the answers as classes. So for example, if I have a regression model to predict sales, my predictions would be 30% testing data sales values, which I'll be comparing that with the actual sales data, which I have it in my test data. Or if I have a classification model, my 30% data will have the actual classes, which I'll compare it with the model which is predicting those 30% of the classes, and then I'll find out whether my prediction model is good, whether it is predicting the required class or not. So once I do the prediction, and I evaluate the results, I see the results, the next step would be to evaluate the model. So model evaluation is to check whether I have high errors or low errors, high accuracy or low accuracy in my prediction model. When I'm talking of regression, I am looking at the predicted value to be as close to my expected value. So for example, if I'm expecting that my sales should be 20, so my predicted value has to be close to 20. So if it is 20 and 20, then the error is 0. If the expected value is 20, my model is predicting 15 or 25. So I have an error of 5. Okay, so I need to minimize the errors. So that is the evaluation technique for a regression model. If I have a classification model, my evaluation will be based on accuracy. That is how accurately my model is able to predict the classes. If I have 0 and 1 as the two classes, where 0 is the false class and 1 is the true class, so out of my testing data, how many true classes have been predicted as true and how many false classes have been predicted as false. So if this number is high, which is close to 100%, then I can say that I have a good model and I can implement this model in the production environment. Now, how do I ensure that my model evaluation is good? Do I need to fine tune the model? So based on the results, and if I am getting a good result in the first iteration or whatever iterations that I perform, now I need to ensure that this result is replicated. So I will be taking different samples of my data. It could be 10 samples, it could be n number of samples that I can take. And then on each of those samples, I'll be fitting the model and I'll be evaluating the results and ensuring that the results are consistent. If I get a consistent result, it means that my model is performing well and it can be used for making real life predictions. Now there are other techniques as well where I can build a model which is giving me consistent results. I can select the best features from my data set. For example, if I have 25 features to predict a classification, now it is not necessary that all 25 features contribute equally to the y variable or the column that I want to predict. So it could only be, let's say, 15 features which are significant. So I can remove those unwanted features one by one and take only the significant features. So it also helps us in reducing the dimension of my data, and with less information, if I'm able to get good prediction, so I will definitely use the features which are less than my original data set. Now, there are other techniques also like optimization technique where I can perform optimization on my algorithm and I can get results. I can do hyperparameter tuning, then I can do transformation of my data. So these are different techniques that I can apply on my data to ensure that I get a good model at the end of the day. So this is how a model is built. Now, whether it is for classification, regression, if I want to do text analysis, a similar technique is used. Now in text, the approach could be slightly different because I'm dealing with the data which is in a textual form. So in a text, there are lots of other things like removing the stop words, words which are not important, converting the data, the text into vectors, and then performing embedding, converting them into numeric form, and then doing the model. So the approach is slightly different, but the way the model is built, tested, and implemented, that is pretty much similar. So this is how a model is built in any AI or ML or DL technique. Now there are three types of models. The first type of model is called a predictive model. So in a predictive model, the prediction is going to be a regression technique. A regression technique is when I'm predicting numbers. So there are two main types of regression, simple regression and multiple regression. Now in a simple regression, I have only one value or one input and one output. For example, I am going to predict what is going to be the tip amount that is expected, and the input is going to be what is going to be the bill amount. So bill amount will be my input and the tip amount will be the output. Whereas in a multiple linear regression, I have one output, for example, sales, and I can have more than one features. So the features could be amount spent in research, what is the production cost, number of employees in the organization, number of offices, what could be the tax implication, etc., etc. So I can have more than one feature which can predict the output. So this is an example of a predictive model. In a decision model, I make a decision, that is whether this record belongs to type A or type B, or whether it is class 1, class 2, or class 3. So it is a classification kind of a problem. So we have already seen that classification is of two types. One is a binary classification where the output is only 2. So I can select one out of the 2. Whereas in a multi-class classification, I can have more than 2 classes where a given record fits into one of the n categories. And finally, we have a descriptive model where there is no prediction involved. I'll be grouping the data into clusters, and the clusters are grouped into based on the similarities. So two records are similar in nature based on the features. They are grouped into something called clusters. So example of clusters, you can have cities based on let's say weather patterns. Then I can group customers based on, let's say, spending scores and their bank balance. So the bank manager knows whom to target if they are launching a new product or a service. So these are the three main types of models that we have in AI. In this video, we saw what is a model, the definition of a model, how a model is built, and we also saw what are the different types of models which is used for predictions.